friends, welcome back to our channel. So in the previous session we have seen the implementation of a stack, which is a linear data structure, and the implementation of a stack can be done in two ways. One is by using the arrays, another one by using the linked list. So in the previous session we have seen the implementation of a stack using arrays. Now in this session we will go with the another linear data structure, that is called queues. Queue. So this is also a linear data structure similar to the stack with a little bit difference, and here also there are two operations to be verified, that is insertion and deletion. So in the stack we have seen the insertion is called as push and the deletion is called as pop. Here the insertion will be called as enqueue and deletion will be called as dequeue. Right? And see, this is also a linear data structure similar to the stack. So it is a linear data structure. The first point, right? So that means all the elements will be arranged in sequential manner. So elements are in sequential manner. This is the second one. Third point. So in the stack, it follows the last in first out mechanism. That means the recently added element or recently inserted element will be removed first. So here the queue is, it follows the FIFO mechanism. So it follows FIFO, F-I-F-O, that means first in, first out. So that means whatever the element inserted first, that can be removed first, right? So best example for this queue is standing on a line for ticket reservation. This is the best example for this queue, right? Standing on a line for ticket reservation. So the person who comes first, he will get the ticket first, right? First come first serve, similar to the first come first serve. So here, in the stack there will be a top position and both the insertion and deletion will be done at the top position, right? So here the insertion and deletion will be performed on different positions. See, here two operations will be there. First one, enqueue, enqueue and dequeue. So enqueue is inserting an element into the queue. Dequeue means deleting an element from the queue. Right. So enqueue is inserting an element, dequeue is deleting an element. And also there are two conditions to be checked while implementing these enqueue and dequeue operations. Two conditions are overflow condition underflow condition. Overflow and underflow. See, these two we have seen in stack implementation. So the definition is same. So overflow means insertion into Q, which is full, Underflow means deletion from empty Q. See, full. So that is called overflow. This is called underflow. So overflow condition must be checked in NQ operation, and underflow condition to be checked in DQ operation, right? Then, so in the stack we have seen another thing that is called a top, TOP, which is a top of the stack. So both the the push operation and top operation will be performed on the same thing, that is top. Here the NQ will be performed on one position and DQ will be performed on another position, right? Let's go with that, and then we will directly go with the implementation part. Right. Here there will be two ends, front, rear. Front points to starting element, whereas rear points to last element. And here also we need to specify the size, okay? So that we will see later. So front and rear. So NQ operation, NQ means insertion, will be done at rear end. At rear. Similarly, DQ will be done at front. That's the only difference. And now the representation of the Q is in this way. So this is the front, this one will be the rear, right? So okay, front and rear. Here we will perform DQ, here we will perform NQ. So if you want to insert an element into the queue, that will be inserted here. If you want to delete an element from the queue, it must be deleted from here, because the first element entering into the queue will be the first element to be removed, right? So this way we have to represent a queue. So this is a queue. This is a queue, front and rear. Okay, so if you are right, so initially the front and rear will be initialized to -1. Initially front is equal to rear is equal to -1. So if you want to insert an element, first we need to update the rear and then we have to insert an element. If you want to delete an element, first we want to retrieve that element which we want to remove, and we need to update the front, right? Hope you understood this one, right? Now, like, we will go with the implementation part. Implementation. How the queue can be implemented. Here also a queue can be implemented in two ways. So first one, by using arrays, another one by using linked list. Right? In two ways we can implement this queue. Now in this session we will go with implementation of queue by using arrays. Right. In the later video we will see the implementation of queue using linked list. Right. Queue using arrays. Implementation of queue using arrays. Now see, initially the front and rear will be -1, and if you are inserting an element, then first rear should be updated, right? So let us see this. First one, we need to fix the size of an array because it is a static allocation. Before starting the queue itself, we need to specify the size, fix the size. So later we can't update the array size. That's the main drawback of implementing the queues using arrays. The same drawback we have seen in stacks also. So that's why we will move on to the linked list. Now let us take the size as some 10, right? Next, front is equal to rear is equal to -1. So both are equal, front and rear both are equal, and both are initialized to -1. Now after every enqueue operation we need to update this one. After every dequeue operation we need to update the front, right? Now let us go with the, so also declare a stack, I mean queue array with a size 10. Now we will go with the enqueue function. So in the enqueue, first we are supposed to check whether the stack is full or not. If the stack is full, then the insertion operation need not be done, right? So we can't insert the element out of the size. So we have to check the queue full. So if rear is equal to size -1, so after every enqueue operation we are updating the rear, right? So rear points to the last element of the queue, so which we have discussed just now. So that's why if rear is equal to size -1, so here the size is 10, so the size of the queue is from 0 to 9, that means size -1. So if rear is pointing to the size -1, automatically that is a queue is full, so we can't insert an element into the queue. So that's why if rear is equal to size -1, simply printf overflow condition, or simply we can print the queue is full. Else, so if it is not size -1, then we can insert an element into the queue. So first read the element, scanf %d ampersand element. Here again we need to check one more condition, that if front is also -1. So because we have to update the front also. So initially this is a queue, this is the queue, so front and rear are -1. So if you insert an element here, let it be 10, rear will be updated, so rear will be pointing here, but still the front is equal to -1. So front should point at the top element, I mean first element. So if we have to check that condition, if front is equal to -1, what we have to do? Just assign it to 0. Then front is equal to 0, right? So if it is -1, is equal to 0. Then after completion of this condition, before inserting, what we have to do? See, so here an element 10 is taken from the keyboard, and now front is equal to -1, so front is equal to 0. So this is the 0th position, 1, 2, 3 and 4. Now front is pointing to here. Front is pointing towards here, this position, right? So let us consider it as F, okay? So F is pointing here. Now rear is equal to -1. So in order to insert an element, we need to update the rear, right? So open the brace, close the brace. So just to avoid the confusion. Here we need to update the rear. So rear is updated. So rear -1. So rear is updated. So the rear value will be here. So that means pointing towards 0. So at the 0 we have to insert an element. So Q of rear is equal to element. So now the 10 will be here. Now the 10 will be here. That's all. Close and close. Once again, if you call this NQ operation, see, rear is equal to size -1. Now rear is pointing towards 0. 0 is equal to 9. False. It comes here. It reads the element. If it reads the 20, then if front is equal to -1, front is not equal to -1 because front is already initialized to 0. That means it's pointing towards the first element. That's why this condition is false. This is a simple if condition, right? Then rear plus plus 0. Now rear will be pointing to 1, right? Then Q of rear is equal to element. Q of 1 is equal to 20. So 20 will be inserted here. So this is the rear position. And again, if you want to insert another element, then again you call the NQ operation. So rear is equal to size -1, 1 is equal to size -1. So condition false, else condition, it reads another element. So 30. So front is equal to -1, front is not equal to -1. So condition fails and out from the conditional statement. Rear plus plus. Now rear will be pointing towards 2. Q of rear is equal to element. So here the 30 will be printed. Similarly 40. In the next call, right? In the next call, the 40 will be printed until this condition becomes false. If this condition becomes true. If it is true, we can't insert an element into the queue. So this is how we can insert an elements into the queue. So insertion always done at the rear end. Okay, that we should remember. So here there will be two positions, front and rear, and all the insertions will be done at the rear end. So first we have to update the rear and we need to insert the element into the rear. Now let us move on with DEQUEue operation, that is how to delete an element from the queue. So hope you understood this insertion operation. It's a very simple thing. DEQUEue. So this is also function. Let us write the function itself. Right. So DEQUEue means deleting an element from the queue. So where we have to delete? From where we have to delete? So all the elements will be deleted from the front end. Right? Front end. So before deletion, we need to check the condition, that is underflow condition. If rear is equal to -1, if rear is equal to -1, simply that implies our queue is an empty queue, because if you want to insert an element first, compulsory we have to increment this rear. So if rear is equal to -1, that implies our queue is empty. That means no more elements available in our queue. So simply we can write printf underflow, or simply we can write empty queue, else. So if it is not an empty queue, then what we have to delete? The first element should be deleted. So element is equal to, this is the array Q of friend. So 10 will be assigned to element. So we can write the printf %d is deleted. Percentage, what is the %d? Element, right? Then we need to update the friend because we have deleted 10. So 20 is the first element. So we have deleted the 10. So deletion means just we are pointing towards another one, right? So the memory will be same. We are not freeing the memory, right? So 20 is, now the first element of the queue is 20. So we need to update the friend. So friend plus plus, friend plus plus. So friend will be moved to here now, right? Okay, then close. Hope you understood. Every time the element is deleted from the front end and we are incrementing the friend. And here we can also check the condition. Rare is equal to -1 or friend is greater than rare. This is also one condition. So if friend is greater than rare, so deleting one by one element, the friend will be pointing towards here. So 4 is greater than 3. That means no more elements are there in array. In queue. So that's why we can check this condition also. Friend greater than rare. Friend greater than. So if any one condition is true, automatically that indicates this is underflow. That means the queue is empty. So this is how we can delete an elements from the queue. See, rare is equal to -1, false. So initially, let us see here itself. Underflow, else element is equal to Q of friend. So 10 will be removed and friend plus plus. Now friend will be pointing towards 20. Again, if you apply this DQ operation, rare is equal to -1, false. So 1 is greater than 4, false. So total false, else part will be executed. So element is equal to Q of friend. So 20 will be deleted and friend plus plus. So friend will be now here itself, right? Again, rare is equal to -1, false. Friend greater than 2 greater than 3, false. So element is equal to Q of friend. 30 will be deleted here and friend plus plus. Now friend is pointing towards the same thing, R. Rare is equal to -1, false. Friend greater than 3. So 3 greater than 3, false. So underflow, again false. So else part will be executed. That 40 will be deleted and friend plus plus. So now friend is pointing towards 4. Now again, if you are applying this, if you are deleting this DQ operation, you are applying this DQ operation, rare is equal to -1, false, and friend greater than rare. So 4 greater than 3, condition is true. So underflow, that means our queue is empty. So this is how we can apply the deletion operation on queues. Right? So hope you understood this insertion and deletion, NQ and DQ. Now we'll go with the third one, that is display. How to display the elements of a queue. That's also a very simple thing. So this is the rare, this is the friend. Right. Now display operation. So we need to display all the elements of a queue. First, let us check whether it is a empty queue or not. So for that we need to check if rare is equal to -1 or friend greater than rare. So this is also condition. If any one of these condition is true, automatically we can say it is a empty queue. Empty queue. Right? else. So if it is false, then we need to print all the elements from front to rear. So we need to use the iterative statements. For I is equal to front, simple for loop. I less than or equal to rear, I plus plus. Here we can print %d q of I. Simple display function, right? So I is equal to front. So I is equal to 0. 0 less than or equal to 3. True. So q of I. So q of 0. That means 10 will be printed. Next, I will be incremented to 1. So 1 less than or equal to 3. True. So q of 1. That is 20. Next, I is incremented. So I is equal to 2. 2 less than or equal to 3. So again true. Q of 2 is equal to 30. So I is equal to 3. The next condition, next increment. So 3 less than or equal to 3. Condition true. Q of 3 is equal to 40. Right? So I is equal to 4. So 4 less than or equal to 3 fails. So it comes out from the loop. It comes out from the loop and the display function will be stopped here. So these are the elements which are presented in the queue. So 10, 20, 30 and 40 which are here. So hope you understood this one, display function. Right? A very simple logic while implementing these queues using arrays. So here only drawback is we need to specify the size of the queue before starting the operations itself. So later we can't change the size of the queue, right? So that's the only drawback in this queue implementing the implementation of queue using arrays. So here the enqueue and dequeue are the operations for insertion and deletion. Enqueue will be done at rear end, dequeue will be done at front end. So in this session we have seen the enqueue operation, dequeue operation and display, how to display the elements of a queue. And right, so hope you understood this session. So let us stop here. If you are having any doubts regarding this session, so feel free to post your doubts in the comment section, so that definitely I will try to clarify all your doubts. And if you really understood my sessions, like my sessions, share my sessions with your friends, and don't forget to subscribe to our channel. Keep following. Thanks for listening. Thank you very much.